If it looked like this, E of 7 equals 7h, then that means you're plugging in 7 for h over here. Because my function is E of h, or it's the f of x, right? E of h. So the number of hours she works is the number that you plug in for h. If she did work 7 hours, we would plug in 7 for h.
You did.
I didn't. I did on the yellow. But that's not what they did. I made that 7. So like if I worked 2 hours, then I would write E of 2 equals 7 times 2.
Excuse me, teachers. 7th graders need to be let out of class at 2:25, please. They need to go to the gym at that time. 7th grade volleyball players need to be let out of class at 2:25, the girls, and they can go to the gym at that time. Thank you. Thank you, Chris.
Thank you, Chris.
Okay. So does anybody else have an interpretation? Maybe a better one now that I've kind of explained that part.
For each hour she works, she gets $7 worth of earnings.
Okay, that's true. And that's really close. If I was looking up here, I want you to think of all this as one thing. That's all your f of x, or your e, or your y. That's all one term. And so, this whole thing on the left side represents what? That's her earnings. All that together is her earnings. How much she made. The money. So if I had to describe it, I would say Maria's earnings. And then what's next? Equals
$7 an hour.
So $7 an hour. So that's correct. If I want to make it a little bit more math related, I would say 7 times the number of hours she works.
Oh, well then the EH should be dollars per hour, right?
Her EH is her total amount. The total amount she makes is $7 times the number of hours. The 7 is her rate. That's her pay rate. She's getting paid $7 for every hour. So if she got bumped up to $10 an hour, what would that look like?
10H.
E of H equals 10H. So the number is the rate. It's not how many hours she worked, even though it's beside the H. Right? It's being multiplied by how many hours she worked. Okay, when I look at the top one, E of 0 equals 0. What does that mean?
She works 0 hours.
How do you know she worked 0 hours?
Because
Which number are you looking at that tells you that?
the 0 in parentheses.
The 0 in parentheses. That tells me
Earnings.
how many hours she works.
Oh.
Now the number inside tells me how many hours she worked. And then this whole thing tells me the amount that she earned.
She would make that.
So she worked no hours. And made no money. What about the bottom one? What is that telling me?
That she worked 3 hours. She worked 3 hours.
She worked 3 hours.
And she made $21 in 3 hours she worked.
That's fine. So what we've decided so far is that my variables are P and T. We said P stood for number of people, was a variable. And we said T was years after 2000. And then we decided independent. We decided the independent variable was time. And the dependent variable was the number of people. The number of people who had a cell phone depends on how many years after 2000 it is. Because you say it the other way, the number of years after 2000 depends on the number of people. Do years depend on people? No, years are years. But the amount of people that do something or that exist would depend on how many years you've had to do that thing. Okay, so here are two examples, and this is on your paper. I want you to think about what do each of these equations tell us about smartphones ownership. So remember what each variable represents. And now we're going to look at it in function notation. So I want you to take these symbols and I want you to write in words what you think it means. I'll give you 90 seconds. Now just a little hint, because this problem is a little tricky. I'm just going to tell you it's a little tricky. Make sure you read back above it what each of the variables means. Okay, make sure you're reading that.
I hope I'm right.
You can't put this in words?
Can I ask a question?
Can you ask me a question? Yes.
Is the negative 10, does that mean before 2000?
I can't tell you that. I can't tell you that. That's a good thought though. I like where your brain's at. In your head. What's that supposed to mean? I like where your brain's at. Okay. Pick a number, 1 through 25. 18. You already went though, right? You're 18 before. Pick a number, 1 through 25. 17. 17. Nobody's claiming to be 17? Oh, Jez Morelli. Okay. On A. What do you think those numbers mean? If you had to put that in words. That's okay.
I think 17 means people and the other one is
Okay. So you think 17 represents there are 17 people?
oh no. Time.
17 represents time?
Yeah.
And 2,320 represents people?
Yeah.
Okay? So
I think she's right.
I think that is also correct, but I think I want us to be a little more specific.
Can I say what I said?
So
No, I want to do B.
let me say this. The 17 is in the position of T. It is my time, and this would be the number of people. Okay? But again, if you look back at the top, there's a little bit of a trick. Tay, let's see if you figured out what the trick is.
Oh yeah. So in 2017, a total of 2,320,000 people. Million.
In
Cell phone.
2017. Why do you think it's in 2017?
Because it says
After the year 2000.
Because the 17 represents how many years after 2000. So 17 years after 2000 would be 2017. That was the first part of the trick. So you're right. This is in 2017. And then what did you say? There were
2,320,000.
2,320,000
Yeah.
what?
People that had a cell phone.
People with a cell phone.
Yes.
I think that's a lot of people.
Not really. Not really.
What do you guys think about this answer?
Lovely. Sensational.
It's not quite correct.
What? Nah, you lying.
Why is it not right?
I'm going to tell you. I'm fixing to tell you. What does P represent? Read it again.
Years after.
P. P. Read P.
Number of people.
People.
Read it. Read it at the top.
The function
P.
gives the number of people in millions.
Okay, so if this number was 1, that would mean what?
1 million.
1 million.
So it's like 2 billion?
This means there's 2,320
I said that.
millions.
That's what I said.
So,
Wrong math.
right, so the math is off. I told you it's a little double trick. So, here is what you need to do.
2,320,000?
Yes, but I'm going to show you why. Because, again, that's a little hard to think about. Remember, if the number was 1, that means it was going to be 1 million. So this would be,
actually be like 2 point.
so this is hundreds, thousands. And so if it was a 1, that means we would put the 1 here for 1 million. But it turns out there's 2,320 millions, which in turn is 2,320,000,000
That makes a lot more sense.
people with a cell phone. So y'all thought 2 million was a lot of people with a cell phone?
I didn't know that was not a lot of people.
Do you know how many people live in the U.S.? It's about 700 million. About 700 million people live in the U.S. In the world, there's about 7.7 billion people. So this would be about 30%. About 25 to 30% of everybody in the world had a cell phone in 2017.
I was close. I just
Okay.
like the wrong zeros.
Okay.
So let's finish the sentence. In 2017, there were 2,320,000,000 people with a cell phone. You understand how we're putting context with this? How you're taking what the problem is, you're looking at the math symbols, but I know what those symbols mean. Those symbols mean words. This is super important on the ACT because the ACT questions are all about context. They're all word problems that you have to then convert to math. So you're practicing those skills whether you know it or not. Honey, that's it? In 1990, man, we were living.
Sound like a whole dude at a park.
What's the other number you get? What's the other number up there?
I thought there was 0 cell phones at the time, though.
There was. In 1990, there were 0 people with a cell phone. I mean, y'all think cell phones are that old? I know that it's crazy how fast tech has grown.
Cell phones are from 2007.
I thought they were pretty old.
I got my very first cell phone in 7th grade, which would have been the year 2005.
That's when an iPhone.
2005. I got my very first cell phone. My parents didn't have a cell phone until 2004.
Alright, I just read that. It says smartphone. Y'all can't say cell phone like the
It's
with the numbers.
They're the same
They have
thing.
the same thing on them.
Right here.
Yes, that's what they were. They were flip phones. Now you're right.
Shut up.
Now why are y'all all screaming at each other? If we can't have a class conversation, we're going to be in trouble. It's going to be a bunch of me giving you worksheets and y'all just drilling practice. So you need to all pay attention at once. No. So smartphones, you're right. A smartphone would be a phone that could connect to the internet.
Yeah, like 2000.
And it was in the mid 2000s when that, but cell phones were new then too. Like cell phones probably started in like 2001,
iPhone came out.
2000.
I didn't know that. I thought they were in like the
No.
early 90s.
Just-
late.
Just because it says 0 doesn't mean no one had it. Like that's in millions. So like it could have been a few. You know.
0 million.
That's also a good point. It is 0. There were no millions, so there could have been a few hundred or a few thousand. But you could have also written that as a decimal, which they probably wouldn't have.
Yeah.
You could have put 0.01, which would mean there was 1/10 of a million, which would mean there was 10,000
Yeah.
people. But they didn't write it like that, but that is a good point to think about and look. 2A, in 2010, the number of people who owned a smartphone was 296,600,000. How could we put that in symbols?
P
P of
10
10.
equals that number.
296.6. Yeah. That's
Okay, so it's not going to be the whole number.
It's gonna be 20.
It is going to be 296.6
Yeah.
because it's in millions.
Because if it wasn't a billion, it would be a billion.
So we always stick with 2,000, like whatever year.
Yes, because they have established what the variable means. And the variable is the number of years after 2000.
Okay. That's what I was, I couldn't even get it.
Now, now you can you could set up your variable however you wanted to. But in a lot of word problems you will see it set up just like this. B part, in 2015, about 1.86 billion people owned a smartphone. So what would that look like?
P 2015 equals.
1860.
That's correct.
Why can I never write the numbers? I think I might.
P of 15 is 1860. What would happen if you didn't put this 0 at the end?
It'd just be 186,000.
It would be 186 million.
Oh, yeah.
Right, 186 million, which would mean that's fewer than the one above it. Right, so you need this other 0.
It'd have been decreased after 2015.
Yeah, that don't make sense. Cell phones didn't decrease. Are they decreasing?
No.
Not yet. It'll happen eventually. You just wait. There'll be something new.
The beginning of the
What? What would be new?
I don't know.
What could be?
Everything's going to be augmented reality. You're just going to have a contact you put in. You can contact whoever you want to by looking. Now, who knows what's going to be next? I'm telling you, it'll happen.
The paraphone's gonna be a thing.
People never thought that newspapers would go away.
Oh, it went away quick.
Oh,
Cell phone.
like that.
Hey, they still have them.
We go to. Yeah, we do, but like we don't use them. Like,
Exactly. That used to be the way you got. Sorry, we gotta get through this. This is my fault. I'm getting us way off topic. 3. Maya's curious about the value of P of T equals 1,000. What would the value of T tell Maya about the situation?
The years after 2000.
So T is the number of years after 2000, but what is she looking at specifically? She's wanting to know.
How many years, or what year
Yeah, you're saying in what year?
did 1,000? I can't say it.
So 1,000 millions, which is what? What's 1,000 millions? It's a billion. So she wants to know in what year did 1 billion people have a cell phone? That's what A is. In what year did 1 billion people have a cell phone? That's what she's finding out. And it wants to know, what are 4 possible values here for T?
4.
Yep. So we said, what about smartphone usage? We said that it was always going to be going up. There's no way that it went down. So in 2010, was there 1 billion people that had a smartphone?
no.
In 2015, were there 1 billion people that had a smartphone? Yes. There's over 1 billion. So when did they get to 1 billion?
Sometime
Between 2010 and 2015. So what are the possible values of T that it could have happened?
2012.
It could happen in 11, 12, 13, or 14. Those are your four possibilities. Right? They set it up for you. They laid it all out. They wouldn't let you fail as long as you can interpret it. So it'd be 11, 12, 13, or 14.
Yes.
Okay.
Oh, I didn't read. I read it wrong.
See?
I read it wrong. I read it wrong. That's my fault. Do you see my thinking? These are four possible values when we get to a billion. The question is 4 a possible value? So in 2000, so no. The answer is no. In 2004, this was not a possible value. My fault, but my logic's still there.
It's very okay.
My logic's still there. It had to keep going up. There's no way in 2004 we were at a billion, and then we came back down in 2010. Right? So it's still the same thinking, the same things I was telling you before apply. So now let's put this on a graph. So what points do we know? Well, we looked at in 1990, which was at negative 10. What happened in 1990? Nobody had a cell phone. So at negative 10, we're at 0. So I need to plot that point. Okay, what are some more points that we were given?
2010.
We were given 2017. 2017, we should be at 2320. So if I go to 17, so I'm going over to 17, which is here, up to 2320. So here's 2000. What's this line represent?
2,300.
This one's going to be 2,200. How do we know that? Because it's halfway between 2,000, 2,400. So this is 2,300. It's going to be just above that. So 17, 2,320. So again, it's hard for me to do on my iPad, but it's somewhere right in there, just right above that. We know in what? At 10, we should be at 296.6. So if I go over to 10 and up to 296, so this is 200. 300 to be halfway. So 296 is really close to 300. So at 10, we're here at about 300. At 15, we should be at 1860. So 15, 1860. So again, this line is 1800. So 1860 would just barely be above that. So I've got a general idea of what the graph looks like. Right, look, there was nobody in 1990. There still wasn't very many in 2010. That's when I got mine. Right, I mean, that's when it's finally becoming readily available. So I can tell you kids didn't have them before 2010. Who had them in this portion? It wasn't children. It was business people that need to connect to the internet. It was people that traded stocks instantly. It was the wealthiest of the wealthiest that had a smartphone. They used to be on Blackberries. Y'all look up Blackberries. That was the very first smartphone that was widely used. So what would the sketch of my graph look like? Well, it's going to be low. Right? You see how I'm staying close to 0 the whole time? And then we'll finally start growing there at the end. And now what's fixing to happen once I get to 2010? It's fixing to look like a rocket. It's going to look like Cannon Man. So this is the general idea of the shape of the graph. Do we understand how we interpreted that?
Yeah.
Do you kind of see the importance of the words behind it for what we're doing? I'm telling you, if y'all can get a hold of this and grasp what all those mean, you don't know how easy your math's going to be. I promise.